So sometimes with integration by parts, you have to do it more than once. So remember, we use integration by parts when we have to integrate a product that does not lend itself to a U substitution. So let's do an example. So we'll have x squared e to the x plus 2 dx. Okay. So if you have the option, if one of the factors in your integrand is a polynomial, or a variable raised to a positive integer, that's what you should choose to be u. So let's go ahead and write down our rules for integration by parts. The integral of u dv equals u times v minus the integral of v du. So it's when you're integrating a product and you can't do something nice, so you might be thinking, well, right, you've always said if you have e to the something, make that something be your u, and you can, right, so walk through what that looks like. So if I let u equal x plus 2, that's awesome. Du is dx, awesome. I still have this x squared out here. It has to be, right, I've taken these two things to u's. That means this would have to go to u, which means it's still going to have a product in there that's not nice. So integration by parts is the way to go. So here we go. We'll let u equal the x squared, which means dv is the e to the x plus 2 dx. So then we go ahead and do du is 2x, and v, so now we'll do a quick little u sub. We'll do it in our heads. So what we were kind of talking about, so u is u is x plus 2, so du is dx, awesome. So I don't have to do any scaling for that. So v will just be e to the x plus 2. So now I'm ready to rewrite my integrand using the right-hand side. So go ahead and write it how it started. Integral of x squared e to the x plus 2 is equal to uv. So x squared e to the x plus 2 minus the integral of v e to the x plus 2 du. Oh, and I forgot my dx there. V du. So that's a 2 and x. I'll squeeze that in there. dx. Okay. So you might have noticed right from our title, more than once. So now when I look at that second term in my integration by parts, I have another product. I have x times e to the x plus 2 dx. So we have to integrate by parts one more time. And we're going to go the same way. So we're going to let the x, right, the polynomial term be the u. So u equals x, and dv equals the transcendental term. I haven't used that for that term yet. So the trig term, the trig factor, the exponential factor, right, that's going to be our dv. Okay, and then du equals dx, and v is e to the x plus 2. We've done that already. So here we go. So now we're just working on that second part, and be careful because it does have that minus in front of the whole thing. Okay. So I have this term, x squared e to the x plus 2 minus 2, some big old brackets. So now I have u times v minus the integral of v du. I'm going to worry about my negative sign at the very, very end. I'm just copying down everything. X e to the x plus 2. So this last antiderivative is just, right, that e to the x plus 2. Okay, so now I'll take the negative 2 through. So I have x squared e to the x plus 2 minus 2x e to the x plus 2, and then plus the two negative signs, e to the x plus 2. So those of you who will be going on to differential equations, I want you to take a look at this. You can go ahead and factor, right? Everybody has that e to the x plus 2 in it. you can pull that out and look what gets left, right? That nice little trinomial, quadratic trinomial. Okay, that's going to come in handy soon. I'll go ahead and add my plus c on there just to be official. So sometimes you're going to have to do this integration by parts more than one time.